Now we are going to discuss the type of the lamps which has to be selected in the case of a street lighting, road lighting, or in the case of area lighting. So earlier we were using with incandescent lamps years back, and after that when the technology has improved, we have moved on to fluorescent lamps and then the discharge lamps, and we were using the low pressure sodium vapor lamps in many of the cases because it is highly efficient when compared to other type of lamps. And after that, a technology revolution has came into picture with the advent of LED lamps. So the LED lamps are more efficient and it produces good color rendering index, and in many of the places nowadays we are using LED lamps. So LED light fixtures for street lights are used in an extensive manner in many of the cases. Next we will see the design formula in the case of street lighting. So this is the basic formula. Initial lumens is equal to illuminance into area divided by LLF into coefficient of utilization. And this is the basic formula which we had while designing our interior lighting. And here area is nothing but width into spacing between the lamp poles. So it is width of the road into spacing between the lamp poles is nothing but area of the road. And light loss factor is either it will be given or sometimes it will be given as lamp lumen depreciation and lamp dirt depreciation. So if you have to multiply in order to get the light loss factor. Now if LLF, CU, area and the amount of illuminance is given to you, then you can calculate the spacing, where W is indicating the width of the road. Ln is the initial lamp lumens into LLF into CU divided by illuminance into width of the road. So design considerations are, it is necessary that the illuminance directly under the luminaire to be same as the midway between the poles, that is to have a uniform illuminance throughout the road. Next is spacing to the mounting height ratio. Mounting height is nothing but the height of the pole. Spacing is nothing but between the poles. It should be a value between 3 and 5. The ratio of average to minimum illuminance should not be greater than 3, and for residential areas it can be as high as 6. And we have seen the various ways of pole placements: one-sided, two-sided, then davit, then staggered manner. So in that, the most three popular models are continuously spaced on the roadside with a spacing of S meter, staggered spacing on both sides, and spacing on opposite sides of roads with a spacing of 2S meters between the two consecutive poles on the same side. And this is nothing but the spacing between the consecutive poles. So that is with the case of road lighting. Now we are moving on to the area lighting. Illumination of a very large area. It can be a yard, it can be a vehicle parking space, an airport parking space. So the type of luminaires which is used in the case of area lighting is almost the same as the road lighting. And there are certain limiting factors like the mounting height, color rendering property of the light source, and spacing limitations. You can just imagine a stadium, how it has to be lit. It's an area lighting. So spacing between the poles shall not be more than 4.5 times the height of the pole, and spacing between the edges of the area and the nearest pole shall not be greater than 2.25 times of the mounting height. And minimum of 2 lights per pole shall be employed for even distribution of light. That is, in a single pole you need to have 2 luminaires. So that is with respect to the lighting systems. And next we are going to discuss on the design considerations in the case of high-rise buildings. So in the case of electrical wiring systems or electrical design, in the case of high-rise buildings, we will be using a concept known as rising mains. So for large multi-story building where there are several floors, it is having many number of sub-circuits, many number of switchboards. Then for the ease of design and wiring, we will be using a technology known as the rising mains. So we will be placing the sub-distribution boards in convenient positions on different floors, and all the sub-circuits are taken from them. And at each load point, branches with the conductors of smaller sizes are taken off, or a pair of fuse is inserted. And we will see a picture of this rising mains, which will give you a clear understanding of what is meant by rising mains or risers. So the conductors constituting the main branch are known as the rising mains or risers. So that is being visible from this particular figure. So you'll be having an incoming cable which is having R, YB and neutral. A cable trench will be there which is moving in vertical direction like this. So you'll be having R, Y, B and neutral, and you'll be taking the supply from each of the floor from the rising mains or the risers. So this is the first floor, second floor, third floor, fourth floor, like that. So for the ground floor, supply is taken from here, first floor supply is taken from here, second floor supply is taken from here, and third floor supply is taken from here. So basically these are distribution boards from which connection is taken to each floor, and then you will be having sub distribution boards in each floor in order to give it to various houses. So R phase, Y phase and B phase, and you will be connecting some consumers to the R phase, some to the B phase, so that you need to get a balanced connection in each floor. And the tappings is being taken like this from the rising mains in order to give it to each floor. So this is how the system is looking like. A vertical bus bar arrangement. These are the risers, red, yellow, blue, and then you have the neutral. So that is again shown over here, red, yellow, blue, and then you have the neutral. So from here you will be taking the tappings from these connectors which is connected to the risers, and from there it is given to the. So there are various arrangements of connecting electrical supply to the rising mains arrangements that I will share the notes with you. Okay, thank you.